Hi guys, so here's a quick tutorial on implementing word2vec from scratch. Now why you would want to do that? You want to learn the inner mechanics of word2vec so that you could make improvement on them, and that's how people came up with doc2vec, and later on continuing on that journey they are today at with transformers, the state of the art vector representation in NLP. So I will refer to this blog, and of course I have my code, so I will go to that. Now this is a very good blog, and this does implementation of word2vec from scratch. Now this guy is using NumPy, and I'm going to use some of his code, and excellent work. Shout out to this guy, Jake, and then I will put this in my reference while uploading the notebook, so that you could play around and you could look up to this thing, this blog as well. So what word2vec is essentially is a vector representation of text, with vector representation of text which has context. So it's not just any arbitrary numerical representation, or even though there are some meaningful ways, for example TF-IDF, and then we have bag of words as well, but they do not capture the context. So what word2vec, the philosophy of word2vec is, you will know a word from the company it keeps. So that's where the concept of windowing comes. So you have this window size. So let's say there is one target word called back alleys. So you have context word, so towards the left and towards the right. So you know back alley from the company it keeps. Now usually we remove the stop words as well, but then I'm not going into that. There are so many optimization which could be done here. Just want to keep things basic. So based on your text, you create sort of a table structure like this. You need to have a pairs. So you see that back alley is paired with something towards the left and two words towards the right. So you prepare the data frame like that, and then you one hot encode them, and then you just use one hot representation of this whole thing, and that thing. So you keep that thing as y, and this as x. So you take all the words essentially, and then tokenize it, and then you one hot encode, and then replace them with this data frame. So imagine this is your data frame x label, and this is y. So you are going to one hot encode both of them. So I will not go too much into this blog. I would like you to read it, but sort of at a high level view I would like to cover. So you have this one hot representation of so let's say you have 5 words. So you have that represented here, and then you want to have 3 dimensions for them. So as you know that weights are nothing but a matrix. So we are essentially going to use 3 dimensions there, 1, 2 and 3. But in my code you will see that I'm using 10 dimensions. Even Jake is using 10 dimensions. So we could have more. So the more dimensions the better actually. It helps in more generalization. Then we multiply these vectors and then get the embedding, and then we with that embedding. So this is a transient thing actually. This is not stored anywhere. So this is the weight that we have, and we get this embedding, and then we multiply it with another layer. So another so deep learning, in deep learning, if you have not seen my video, so this may sound unfamiliar to you, and if it does, so go back and watch my videos, and then come back here. It will be super useful. So we have this sort of another layer. So we are multiplying that matrix essentially with the embedding to get the output, and finally we pass it through softmax, and then the output that we get. So the predictions here, these are our y hat values, and then we already know the y, the labels. Then we have this cross entropy loss function, and then finally we find the gradient of that, and then we update. Now what I'm talking about, if it doesn't make sense, again go back to my previous videos on deep learning, come back here. It will just sound easy. These are some of the basic stuffs in deep learning. So I will not go too much into math because I have already covered in my deep learning videos. So I just want to give you an overview how word2vec works. Now we can go to the code. So I have this borrowed Jake's code here, and then I will just quickly go through that. And then before I go in the TensorFlow part, because I have modified Jake's code to use TensorFlow, because why not? Everyone uses TensorFlow. So we are essentially tokenizing everything that we see here, and then we convert it into a dictionary so that we have unique numbers for every word. And then we want to one hot encode, so we want to iterate over each item based on the window size. So we want to create that data frame that we just saw. So let's look at that quickly. This one. So that's what we are doing here, x and y. And then finally we concat, this is our utility function, and then we can see the shape of x and y, which is same, and it should be. So we could see one of the items there, and that is indeed the one hot representation. Everything else is 0. So this is for y. And then this is my code from previous tutorials. So I'm just batching out the data that we have. And this is the model. So this is where my code deviates from Jack's code. So I'm using TensorFlow, and again this code is from my previous video, so just check that out and then come back here. So I want to create one, so this is our first hidden layer, and this is our second hidden layer. So with this is the vectors that is going to be useful for us, and this is what used for the embedding. Which is the transient thing generated that we just saw. So here we have vocab size and then the number of dimensions, which is exact same as we saw that no matter how many words, so correspondingly we have a matrix. So let's go back to that so that it makes sense. So this is our input space, which is one hot encoder, and that is the weight. So a dense representation of the input space is what we need. So that is the W1, and that thing is learned over a period of time, which means through going through the embedding and then finding the weights, multiplying with the weights, and then output and then softmax prediction and so on. So this W1 are our word2vec vectors. It's as simple as that. If we just capture it, if we just train the thing, and then we take this, so the first row in that W1 matrix, that's going to represent the first word. Why that is the case? That's because, so this is the first row, so let's pull up a pen here. So this is the first row, and you have 5 elements, and this is your first column, you have 5 elements. Now you are going to multiply this thing with that, and again the same row with that and with that, and only then you would get this embedding thing. So you have this sparse representation as a vector in the form of a dense representation. So this is the same thing. So the first row in weight matrix, the W1 weight matrix, is your word2vec vectors, and it applies for all the elements. Okay, so this is my old code softmax from previous tutorial. Only change here is I removed the bias because there is no need for bias here, and then we are not passing it through a double softmax layer here. We are just matrix multiplying. Cross entropy is the same from my previous code, and then stochastic gradient descent is the same. The training loop is again the same, nothing changes there. Now if we pass it learning, we see output like this: improve, experience, artificial. Now they sound familiar, right? So if you are looking for learning, what are the similar words? These look very similar to me. Now we could improve this by removing the stop words, and let's look at the embeddings. So guys, this is our word2vec representation for the whole corpus. So essentially what we need to do is to serialize it, and then serialize that dictionary. So any new word comes, we just take out the index, and then just pass that index into square bracket of this matrix, and we get the embeddings. As simple as that. And that's what we have done here. So even though in the other guy's code, Jack's code, so he's one hot encoding and then multiplying that, but that's unnecessary. We could just index it, and then we get the vectors. So I hope you had fun, and then in the next video I will cover doc2vec. So I'm still going through the paper. So this is the original paper, and I have no clue how we are passing the paragraph ID. Now in the word2vec model, I want to pass a word like that. So I would assume that in doc2vec I would pass a bunch of words, and where the heck is the document ID? So once I figure that out, I'll make another tutorial, and then I will walk you through, make things easy for you. Now this word2vec is by far not complete, so instead of softmax, we should use a hierarchical softmax to improve our training process, to speed it up actually. And then for more robust model, we should use negative sampling as well. Those things I may cover sometimes in future, but so far I will focus on the doc2vec one. And then I want to sort of make a series like this, so vector representation, because NLP, this whole thing is based on vector representation. So I may come up with TF-IDF, bag of words, n-grams, and so on. So basically, how do we represent words in the form of numbers? So this is the first video in that series. I picked a popular one, didn't want to start with TF-IDF, it's kind of lame, so I just went with this. So I hope you had fun, and please post your comments if you have any questions. If you like this video, put your thumbs up, and please subscribe. I'll see you next time. Bye.